now in this problem here, we've got this function. Now it's got a bar over it. That means an average. So what this means is that a producer and distributor of gift card produces X boxes of gift cards, right? So this is the number of boxes that we're producing each day at an average cost. The average cost is given by this expression. So you can see that the average cost depends on the number of boxes that are produced. Now, currently, we're producing 260 boxes of cards each day, and what we want to know is what change can be expected in the average cost if we produce one more box, 261. So we're going to go from 260 to 261. What can we expect? How can we expect this to change? By how much? So we want this to change, so we need the derivative. So what we're trying to do here is we're going to find C bar prime of X. Now it's the derivative, and what we have here is a quotient, so we're going to use the quotient rule, so I'm going to write it this way. C bar prime will be the bottom times the derivative of the top minus the top times the derivative of the bottom, all over that bottom squared, where this takes us. So Z bar prime of X is equal to, all right, the bottom, which is 3x plus 400, right, that quantity, times the derivative of the top, right, there's the bottom, here's the top, the derivative up here, just the 6, minus the top, which is, right, the quantity, 6x plus 5,000, times the derivative of the bottom, which is just that 3, all over that bottom squared, 3x plus 400 squared. A little bit of algebra, we can simplify this, so we're going to multiply in by the 6, so 6 times 3x, so let's write it up here at the top right. So C bar prime of X is going to be, all right, I'm going to get 18x plus, now 6 times 4 is 24, but we've got 2 zeros. And now multiply in by that 3, but don't forget that negative. So I'm going to multiply in by negative 3. So this will be minus 18x, and then minus, well, 3 times 5 is 15, and we've got 3 zeros all over that denominator squared, 3x plus 400 squared. And now you can see on the top here that 18x and 18x, that's gone. So now what are we going to have? C bar of X is going to be, all right, positive, I'm up here now, 2,400 minus 15,000. My calculator shows that to be negative 12,600 over 3x plus 400 squared. And we want to evaluate this at 260. So what we're going to do is get here negative 12,600 over, okay, 3 times 260 plus 400 squared. This looks like a calculator problem, so I'm going to put it in my calculator. And I put it in like this. Here's what I got the negative, not the minus sign, right? The negative 12,600 divided by parentheses 3 times 260 plus 400, close, and then I squared that. And what I got out of this was negative 1, 2 zeros and a 9, and then a 0 and a bunch of stuff here. So I'm going to write this as negative 0.009. So I'm going to say that C bar prime at 260 is negative 0.009. So that's the answer here, is that number right there. But what does it mean? Well, this tells us if we raise the number of boxes of these gift cards that we're making from 260, let's go here, from 260 up to 261, what is that? Up to 261, what will happen to our cost? Well, the cost is going to, you see that negative? The cost is going to decrease by about $0.009. Okay, now if we make it dollars, it's going to be, move that decimal over, it's going to be what? So this is negative $0.009, or move it over, well, it's not even a cent, right? So it goes down just a little bit. But here's an important feature about this. Look back up here at this derivative. Back up here at this derivative. Well, let's go back up here. Look at this derivative here. I'm going to capture that like this. Okay, so that derivative here, look at this. The top is negative, and the bottom, because we're squaring the bottom, it's always positive, right? So that denominator is positive. So I've got a negative over a positive. Now, it doesn't matter what x is, right? The numerator is always negative, regardless of whatever x is. Numerator is always negative. Bottom's denominator is always positive. So this derivative here is always negative, which means that c bar of x is decreasing. So the more cards we make, the lower the cost. And here's proof. It's always decreasing. It will never go back up.